In this example, we're going to look at the series from k equals 1 to infinity of negative 1 to the k plus 1 divided by k squared. We'll note that this is an alternating series because we have the negative 1 to the k plus 1, which is going to alternate the terms of this series between positive and negative, right? And our a sub k, right, the absolute value of the terms of this series, the a sub k is just 1 over k squared, right? When you get rid of the negative 1 to the k plus 1, you're just left with 1 over k squared. And you'll note that the a sub k is positive, so we can just make a note that 1 over k squared will always be larger than 0, and that's, we need that for an alternating series. We need our a sub k's to, in fact, be positive. Now, to show this series converges, we'll use the alternating series test. And so there are two things that we have to show about these a sub k's to be able to use the alternating series test to show that this converges. So we need to show the first thing we have to show is that the terms of this series are decreasing. In other words, we need to show that a sub k plus 1 is always less than or equal to a sub k, right? The next term is always less than or equal to the previous term. And the second thing that we have to show is that as we take the limit as k goes to infinity of the a sub k's, we have to show that that limit is in fact 0. If both of these conditions hold, then the alternating series test tells us that this series converges. So let's check this first condition. Right? And the way that I like to do this is start with something that I know is true and use that to show that a sub k plus 1 is less than or equal to a sub k. Right? So I want to start with something that I know about k plus 1 and k and manipulate that to something that looks like a sub k plus 1 and a sub k. Right? Now, a sub k is 1 over k squared. Right? So a sub k plus 1 would be 1 over k plus 1 squared. So I can note something about k plus 1 squared in relation to k squared. I know that's always going to be greater than k squared. Right? But this implies when I take the reciprocal on both sides, right, I now look at 1 over k plus 1 squared, and I look at 1 over k squared. Well, I know when I take the reciprocal, my inequality flips. Right? So now I have that 1 over k plus 1 squared is less than 1 over k squared. Right? But you'll note that this right here is a sub k plus 1, and this is a sub k. Alright, so we have shown that a sub k plus 1 is strictly less than a sub k. Now for part 2, this limit, we need to show that this limit is 0. So we just look at the limit as k goes to infinity of a sub k, which of course is equal to the limit as k goes to infinity of, well, what is a sub k? A sub k is 1 over k squared. Right? And now this limit, right, as k goes to infinity, my denominator is getting infinitely large. Right? So I've got 1 over something infinitely large, and so this would go to 0. And so that checks for us as well, right? So both conditions 1 and 2 hold. So therefore, we could say the series converges by the alternating series test, which I will abbreviate AST.